Okay, we are reviewing for the Chapter 2 test, and this is in my 3rd hour class. So, I am hoping that we can cover at least a little bit of what we've done this chapter. There's a lot of stuff. It's all about functions. All right, this is with a metaphor. All right, a function is like a machine. And I would even add, I need it to be a dependable machine. If I put a 2 in and I get a 4 out, that's fine. And I don't even make any judgments about how good the machine is based on what it puts out. But if I put in a 2 again and this time I get a 22, that's going to be a problem. If one input ever gives you more than one output, it's breaking the rule. All right, that's in the context of 3 ways you can check by using ordered pairs. So I'm going to give you one. Is this, as far as you can tell, a function? Yes, because it doesn't break the rule. What's the rule? Any one input has to have exactly one output. So if I add this to my list, you can probably guess what I'm going to do here. Now, is it a function? No, because I put in a 3 2 different times. I got 2 different things. It's not dependable. It is not a function. All right, how about if I change it to this now? 4 gives me a 9, and a 6 also gives me a 9. Is that okay or not? Give me a thumbs up if you think it's a function, a thumbs down if you think it's not a function. There's a lot of thumbs up, and you thumbs up are right. It's okay. I know it's weird. It's weird to have... Oh, sorry. I said, okay, some of you are right in the context of what I said. If I change this, is this okay? Sorry, I should have kept this off of here. All right, so now, yes, that was a valid point. Now what I'm asking is it okay? Is this a function based on this 6 being with a 9 and this 4 also having a 9? Is that okay? Yes. It's just if you put in a certain x and you get something different for the y. You put in a certain output, you have something different for the y. Visually, that looks like this. Function or not? No, because by putting a vertical line here, called the vertical line test, I'm testing a bunch of different outputs. Here I'm testing like -2, and it's only having one output. Here I'm testing 0, it only has one output. Here I'm testing like 23, and it's got 2 outputs. See, it's like putting in a 23 for my x and getting 2 different y's. Like, let's say that's 7 and that's 10. I can't do that. That's not allowed. Okay, so the vertical line test. The last test, and I didn't spend much time on this before, I said, just because it has an equation, do you know that for sure it's a function? No, because I gave you an example. Do you remember the example of an equation that would not be a function? X equals y squared was not a function. Okay, so here's another way to summarize this. If you can solve it for y, well, you can solve anything for a variable. But if you can solve it for y and only get one answer, then it's a function. So let me go to this one. Is this solved for y and it's only got one answer? Yes. If it had a plus and minus in front of this, then really that would mean y equals positive x squared plus 3 and negative x squared plus 3. That would not be okay because that's 2 different functions. One of them is it's going to overlap with the other, and you're going to end up with multiple outputs when you put in an input. Okay, so moral of the story, I give you an equation. You see if you can solve it for y and have only one answer. Solve it. It's good practice anyways. You need algebra a lot. While you're doing this, I'm going to remind you, the top 20s. Some of you guys were terrible on your first top 20. You got better on your next top 20, but you're still not awesome. I had a lot of like 10s out of 20. That's 10 skills that are still hanging out there. If one of them's on this next test, you're going to get it wrong. I told you, those top 20s will come in handy all throughout this year. They're all things that are going to come up at some point. We've already had distance formula come up. We've already had midpoint come up. Those are 2 of the top 20s. And all of those 20 are going to come up. So please take the time to learn them. Over this weekend would be another good time. You're that much better prepared for this test if you've got the top 20 nailed down. Okay, did you solve this thing by subtracting 2x from both sides? That would have been wise. And then dividing by 3. And now it's solved for y. Did I only get one answer? Yes, one equation. I didn't get like a plus and a minus. What do you even mean by that, Mr. Server? Well, if I told you this one doesn't work, right? Would you please solve that for y? Gentlemen, would you please solve that for y? And I don't want to hear the line, I solved it in my head. Well, great, but write down the answer on your iPad. No, I can tell you haven't finished because you have nothing on your iPad. Don't. Going again, we are solving this by taking the square root of both sides, and I end up with square root of y squared is not y. It's the absolute value of y equals the square root of x. And then you're supposed to know that gives me 2 answers. It gives me y equals the positive square root of x and y equals the negative square root of x. And I don't want you to misunderstand and think, oh, it's plus and minus that. No, it's not. If you're saying that, you are not understanding a fundamental thing in math. If I have x squared equals 16 and I square root both sides, the answer is not x equals plus and minus 4. That's wrong. Because then you're saying the square root of 16 is 4 and it's negative 4, and it's not. We've graphed, you could graph that if you wanted to. It's just one number. It's 4. It's not a negative 4. All right, so what happens is it's the absolute value of the x equals 4, and that's what leads you to have 2 answers. X equals 4, x equals negative 4. All right, so be smart about this. Don't just slap on a plus minus. It will come back to haunt you later if you don't really understand that. Okay, look, I solved. I got 2 equations. What does that tell me? Not a function. At least I can't guarantee it's a function. There may be even problems where you could solve it, get 2 equations that happen to both work out. So, but here's the thing. If you can't solve it for y and just get 1 equation, you can't trust that it's a function. All right, so that covers the first 3 topics up here. Families of functions. Well, do you remember there's a whole bunch? How many functions did I tell you? They're the main big precalc functions. 12. There were 12 of them. You knew 6 coming in here, at least by my calculations. You seem to know 6 of them. The other 6, let's just review a couple of them real quick. But I think you'd agree that since that's something you can look up in your notes, that I shouldn't spend all of our precious time just reiterating the 12 functions that you can just look up. But here's one of them. Remember that guy? What function is it? It starts with a word, or with an L. Logistic. That's the logistic function. And it's y equals 1 over, and that 1 could be any number. It's whatever limit you want it to be. If I want this thing to limit out at 150, I could put 150 over 1 plus e to the negative x. All right, you have 12 functions you're supposed to know. You got a list. Look back at your notes. Know them all. Can you tell the difference between sine and cosine? What's that one? It's cosine. Cosine is a valley. Starts at 1. If it was sine, where would it have started? 0. Sine goes like this, etc. Okay, moving on. Let's talk about how you can move functions. Y equals negative 3, negative x plus 2 squared minus 8. Would you agree that this is a parabola at heart? It's just been moved and flipped and stretched and all that kind of stuff? All right, some general rules. Did I talk about high-vo in your class? Horizontal on inside. What do you think VO stands for? Vertical on the outside. Okay, high, low. This stuff's on the outside, so that's a vertical thing. That is a move which direction? Down, what? 8. How come it's not up? Well, you've got to just trust the stuff on the outside. That -8 seems like it's moving down into the negatives. It is. You can trust the stuff on the outside. That's another theme. Okay, so in here, that's a vertical what? Stretch. And what's that guy? That's a reflection. It's a what kind of reflection? Horizontal or vertical? Vertical, because it's a vertical on the outside. That's a vertical reflection. And then the last are on the inside. So this is a reflection again. So since I gave you the little rule, it's horizontal on the inside, you should know it's a horizontal reflection. And then the last thing is that little move, which is a horizontal move, and therefore is it left or right? That's left 2. It seems like it's right 2, but you can't trust the stuff on the inside. Give you another one. Y equals 2x squared. 2 is on the inside. So horizontal. Seems like it should be a stretch, but you can't trust the stuff on the inside. So horizontal shrink. It's half as wide. All right, that's a quick reminder of families of functions type of stuff. Next is domain and range with A and B. Would you just tell me what's the domain and range? I'm going to give you kind of a weird one here. Let's say that I had a function that gets really, really, really close to this, and then it kind of heads down that way. What's the domain and range of that green function? Write it down, please. Use interval notation. So like 4 to -infinity or whatever you think it is. Now, would you please compare with the person that is sitting first and second row right across from you? You guys make a triangle in the front here. Second and third row, you guys, no, third and fourth row, you guys straight across. Fifth and sixth row, straight across, and there's 1, 2, 3, 4, 5 here and 5 there. It should work if you go straight across. Slide back just a smidge. Thank you. Domain and range, please. Domain and range. Okay, so you should have said the domain is from left to right. It's the x's. And how far is the furthest it could possibly go to the left? Well, it kind of doesn't say exactly how far over that dotted line is, does it? This is where we could incorporate A. Okay, how far is that over? Well, I don't know. A. Now, would I call it positive A if it's located right here? Nope. Nope. Because if A, in our last worksheet, for example, it had all these things where A is greater than 0, and then it says f of x is equal to A, and then A has got to be less than -2 or whatever. Okay. If this distance, I don't know that distance, but I will never have a distance over here that if I say the distance is A, then I would have to say it is -A if I'm labeling a spot. Okay, so then this is going to go from domain -A, and if you thought I meant that the dotted line was right on the axis, okay, then I'd understand if you had had a 0 right there. Okay, but if the dotted line was meant to be a little to the left of the axis, and how far? A. Okay, then I'd say it goes from -A until, how far does it go to the right? Infinity. That makes sense to you? Okay, and now the range. The range is how low will this thing go? -infinity to how high will this thing go? So -infinity to positive infinity. All right. Give me the domain and range of that. Yes, that is 2. I didn't use an A. Who's got the domain done to their satisfaction? All right, Mr. B, tell me what you think.
Bracket
I would agree with you. The furthest to the left that this thing goes is 2. And the furthest to the right, we don't know. We say infinity. Doesn't seem to be any limit. Okay, how many had that one right? Good. Now, harder one. Who thinks they got the harder one right? I think you caught the curveball I was throwing there. Yes? Range. Good. The first thing people do wrong a lot of times is they forget negative infinity is negative infinity is the smallest thing that there is. So it has to be first if you're ever going to have a negative infinity in your answer. 2, the second part of range is how high does it go? I agree. I don't know, so I'm going to call it A. Now, if you just made up a number for this, okay, but do you understand that you don't really know how high it was? And could you have to call it A? Could it be K? Could it be Y? Sure, you could have a different letter. Yes. Good question. Since it has a filled-in dot, I think you got me there. And I never asked you what you wanted to have for a symbol there, but yeah, I think you're right. I think you should have to have a bracket around it because there's a filled-in dot there. Very good. Okay, so that's domain and range with A included. All right. Wonder where. There it is. Okay. Next is piecewise functions. That's like the Mad Mouse thing, except you're not going to have a calculator where you're going to have to like try to guess and check things, but can you understand them when they look like this? F of x is equal to, I'm going to say 3 things. Let's say it's x squared plus 1 when x is greater than 7. Let's say that it's 2x minus 3 when x is between negative 3 and 7. And last but not least, it's 1 over x plus 1 when x is, let me think now, what should I go up to here? When x is, you should be able to fill it in. There's only one spot left. Let me make sure you understand what I'm talking about here. Here's the graph. Do you get in between negative 3 and 7? It's going to be this middle function. Get that through your head. Does that make sense? In this zone here between negative 3 and 7, it's going to be one function, this function. Okay? And when it's bigger than 7, like this, it's going to be another function. So somewhere in this zone, in that zone, it's going to be this function. Okay, so that only leaves one zone left. Who can tell me what I should be saying here? Yes, sir. Less than or equal, well, not or equal to, you're really close. Less than negative 3. Why can't I say or equal to? Because then I'd have 2 things that own this spot. This owns negative 3, but we can be less than negative 3. Nice job. Okay, so now I could ask you to graph that. That'd be pretty tough. If I had to graph that, I would find points on an XY chart for each of these little areas. Do you get in this little XY chart? It only would make sense to pick numbers less than 3 because I'm in this zone here that's where all the x's are less than 3. So I only should pick x's that are less than 3. Okay. Negative 3, thank you. And in this little zone here, I may as well only pick numbers that are between negative 3 and 7. Okay, and I make an XY chart for that. Okay, good enough on that. I'd just like you to find 1 for me. Would you please find f of 5? Find all the possible answers for that. F of 5. Would you please write it on your iPad and please compare it with the kid next to you, somewhat silently. If you want to try to explain it to them if they're different than you, that'd be good. What do you think it is? Do you have what you think it is? Excellent, thank you. Give it a shot. Okay, I tried to mess with your head by saying all the possible answers. There's only one possible answer. If I'm going to do f of 5, can I stick it into all three functions? No. 5 only fits in there. If x is 5, how could I do it if I'm only allowed to do it if x is bigger than 7? I can't use the top one. I only can use this one. So I stick in a 5. 2 times 5 is 10. 10 minus 3 is 7. Raise your hand if you had 7. Okay, good. Okay, now let's do a little more complicated one. I want you to figure out f of a plus 2 given that a is less than negative 8. That's what makes this a challenge. This is what makes this an honors class. If I wanted easy street, I would have just said use the top function and figure out f of a plus 2. Okay, so some thoughts. As soon as I said a is less than negative 8, I could put a number less than negative 8. Remember that strategy? You pick a number for a that kind of fits. So give me a number that's less than negative 8. Negative 9. Okay. If I put in a negative 9 or a negative 10 or something right there, do you get that I will end up doing f of x where x is a number like negative 7? See what I mean? This total right here is going to be about negative 7 or negative 8 or negative 9 or negative 10 or negative 11. Which of these three functions does that fit into then? This one, or this one? The third one. The third one, because it's a number that's going to be less than negative 3, that's for sure, because we're going to have something like negative 7. So now I know I need to use this function. So then, how many of you knew that we were supposed to use this function? All right, good. Then, hopefully, you plugged in a plus 2 where you're supposed to, which is right there. You'll put a little parenthesis there and drop in an a plus 2. And then you have a plus 2 plus 1. Can you actually add the 2 and the 1 together? Yes. 1 over x plus 3. Or sorry, a plus 3. 1 over a plus 3 is your final answer. Any questions on that? Okay, let's keep moving. So that was piecewise functions. Now, implied domains. Two functions. Let's call them f of x and g of x. That's one of the reasons that we don't just say y equals all the time. We can name them easily this way. Okay, so I got two functions. Do you get how I can feed both of them a 3 and one of them is going to die and the other one's not? Okay, it's like the allergy thing. All right, one of my neighbors is allergic to bees. I was really close to putting in a bee's nest in my backyard on purpose. Why on earth would you do that? Because you can get tons of honey. In Minnetonka, I actually called the police and asked them, is it legal? Like if you kids wanted to have a bee's nest, a hive in your backyard, and they said there is no statute. Now this was, should check, maybe they've added a statute since I called them, but there's no statute against it, and therefore, yeah, you could have your own personal honeybee colony in your backyard. Sounds much scarier to say beehive, but and you can get like 30 pounds a year of honey out of a beehive like that. That's a lot of honey, and all you got to do is basically keep them happy. It isn't super simple, but they're going to get the, go out and get the pollen from the neighborhood flowers. Well, anyway, I was going to do that, and then I'm really glad I didn't, because my next door neighbor has just been diagnosed with the really severe kind of bee allergy. So you can imagine how comfortable they would have been living right next to the guy with 4,000 bees. So I would have probably had to shut it down anyway if I had been gotten started. So anyway. All right, so what poisons a function? Well, anything that makes the denominator we don't want the denominator equal to 0, and we also don't want square roots like here. I'm going to put a square root over that one. We don't want square roots to be negative. So we want to say there greater than or equal to 0. So those are the two little things you need to do. So would you please find me the domain for the f of x function and find me the domain for the g of x function? I would do it in the terms of a number line. This is, I think, a very good tip, because when you try to do these directly into interval notation, it can be very confusing. I want two separate ones. This is not a combined function. This is two separate problems. Find me the f of x domain, and find me the domain for g of x. Do them on a number line. Now, from a number line, it's not hard to translate, so if they ask you for interval notation, you take your number line and you find the interval notation for it. Would you please also write your answer in interval notation? That way, in case you're asked for the one way instead of the other, you can provide it. Okay, so here, always take the denominator, set it not equal to 0, and solve it. So when you have a not equal, I know it's a little weird, but you have x not equal to 3. That is a domain, except technically you have to say all reals where x is not equal to 3. But I asked for a number line. Here's 3, not that, everything else. Raise your hand if you did that right. Good, now the interval notation for it. Negative infinity up to 3, union with 3 to infinity. Raise your hand if you had the same thing on that part. Okay, that's called interval notation. Be good at it. Next kind. I set this greater than or equal to 0, subtracting 7, 2x greater than or equal to negative 7, x greater than or equal to negative 7 halves. So now what? If I put on negative 7 halves, 7 halves, and then I say it can be that, and then it could be bigger than that. There we go. And then if you want interval notation for that, you would say bracket negative 7 halves to infinity like that. Any questions about that one? Okay, so then one last problem that puts it all together. This one is one function, and it's got a top, that's the square root of 2x plus 7, and it's got a bottom, that is x squared minus 1. Remember, if you can factor, you should. So, set these two things, tell me what y of x, no, I usually don't use y, you can call it m of, no, let's call it p of x. There we go. Tell me what p of x's domain is. I'd do it on a number line. I'm going to pause for a second while you do that. I am back, and we are doing 2x plus 7, and what do I set it? Greater than or equal to 0. Okay, good. And now I'm going to go 2x greater than or equal to negative 7, x greater than or equal to negative 7 halves. Okay, and this other one, that one is not equal to 0, and therefore x plus 1, x minus 1 not equal to 0. And what would make it equal 0 is if I had a 1 and a negative 1. So x cannot equal 1, x cannot equal negative 1. Put all of that on a number line, and I have negative 7 halves is about negative 3.5. There's right here, negative 3.5. And it says that works and forever this way. Have I done it right so far? Okay, now I'm going to go x equals 1 and x equals negative 1 are important spots. I have to erase a couple spots because negative 1 doesn't work and neither does 1. So there is your final answer. Raise your hand if you got the same thing as I did. Okay, awesome. So that is implied domain, and that's really important as we move on. Next, let's talk about making functions. Say I wanted a function like f of x that would, well, here's one. What does that do first? You have to do the add 7 first. True or false? False. You're going to have to do the multiply by 3 first, right? What if I wanted you to make me a function like that, except I wanted it to add 7 first, then I wanted it to multiply, I'm going to use an x for multiply by 3 next, and I wanted it to divide by 4 next, and I wanted it to add 1, add 1 at the end. How could you make a formula that would make you add 7 first, multiply by 3 next, divide by 4 comes after that, and at the very, very end, you add 1? It's going to look kind of like that, but it's not going to be super simple. Raise your hand if you think you got it. Ooh, a lot of people think they already have it. Awesome. Give you another 30 seconds here because some people aren't ready. While we're letting them finish up, I'll remind you about the Mad Mouse thingy. It's not due Monday. You don't have to worry about this weekend, but there's now you and there's later you. You can really stick it to later you if you want to, and wait till like 10 minutes before the test and start studying right then, and then later you's gonna be like, crap, I only have 10 minutes to study. Okay, or same thing with this Mad Mouse thing. You can put it off, and then Monday night you're gonna hate yourself because you'll be like, crap, I got that whole project I still gotta write up. I would take some of it this weekend. Maybe play with the calculator, take it with you to the soccer game or whatever, and play with the numbers until you can get your function to like line up right, and then write it up at home or something. But just get some of it done. Be nice to later you. That's one of those things in general that's true in life. If you're in your 20s, you just burn up all the money that you have, and you even go into big debt. Well, you just pooped on later you. Because now later you is going to be like, I have no money. I got to pay off all this debt I had for my 20s. I wish I would have been nice to later me. It's kind of an interesting concept if you think about it. Now you and later you. Okay. So, plus 7 first. X plus 7. If I put it in parentheses, that's going to make it be first. Well, kind of. Sometimes. Depends. So far, I can't really be wrong because there's nothing else to do. Okay, now times by 3 next. Would you agree that that's so far correct? Okay, good. Now I have to divide by 4 next. Okay, now I'm going to write this as divide by 4 this way. And why can I be sure that the top will get done before the bottom? It's like there's a little parenthesis here. Whoa, changed colors. That's weird. And a little parenthesis there. When you have a fraction, a big fraction, there's imagined parentheses around the tops and the bottoms. All right, so now the very last thing I want to do is do a plus 1 at the very, very end. So you just slap a plus 1 out here. And why will I have to get all of this done first? Because there's implied parentheses around the top and the bottom of your giant fraction. Any questions about that? Okay, that's making a function. How about real-world function problems? Let's say that I knew that Elon Musk is the guy who has SpaceX, and he has just created this new rocket that will follow this trajectory. F of x, or f of t, let's say it is, t for time, will be equal to negative 16t squared plus 4t, let's say 40t, plus 4. And it's a rocket that's on this little launch pad, and let's say he just wants to make a rocket to inspire young engineers. So this is like a little personal rocket you can have in your backyard. You can, launch a mouse into orbit. Yes, sir. Good question. I have not set any domain on T. Okay. So there is an implied domain, however, because in the real world, can you have negative time? Okay. All right. So I'd like you to tell me, if he said, we want you to tell us where your rocket would be at time 2 seconds. Do you know how to evaluate that? If I said time is 2, that would be one thing. What if I said, I want to know when the rocket hits 1,000 feet in the air? That's 2 different problems. You do them with 2 different techniques. All right, first one, time is 2. All you'd have to do is stick a 2 in for which? The f of t or the t? When they said time was 2, they were telling you t is 2. So you stick a 2 in there. F of 2 is that, and that's all there is to it. Okay, so this will be 40 times 2 is 80, and this will be 4 times negative 16 is negative 40, 64. Negative 64 and positive 80 plus 4. So 84 and negative 64, I think that's 24. Raise your hand if you got the same thing. All right, did I do something wrong? I have only a few hands, so. 84 minus 64, shouldn't that be 20? I think it's 20. Okay. Negative 16 times 4 is negative 64, isn't it? All right. Okay, so I think the answer is 20. There we go. So what was that? 20 chickens in Bolivia? What is it? 20 feet. 20 feet high off the ground at time 2 seconds. All right. Pretty lame rocket, but anyway. Now let's go to 1,000 feet when? Well, where do we put the 1,000? F of t. This whole thing here becomes 1,000. And now I told you earlier a technique. Did I tell you about graph both sides in this hour? I get confused in which hour I've told. Yeah, graph both sides and see where they cross? Okay. You could graph this. You could graph that without the 2's because that's a different problem. Graph both sides and see where they cross. Okay, that's a great way to do it. Option B, I could subtract 1,000 from both sides and set it equal to 0, and then it's just a normal quadratic with something squared, you know, makes it a quadratic, and then if you could factor that, awesome, but that's amazing factoring skills on your part. So if you can't factor it, there's a next logical word to this. If you can't factor it, say it. Quadratic formula is correct. If you can't factor a quadratic, then you use the quadratic formula on it. I'll lead you in a choral singing. X equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, good. Let's go do caroling at Christmas time, too. We'll do that carol along with the other classics like, sung to the chestnuts roasting on an open fire. We could do like something with Fee and Pie are out playing in the snow, or anyway. Okay, moving on. How about this? Actually, there's one like this on the smart board that I'd like to attempt with you. I believe it's a good one. So, would you please find in the smart board, not that one, in this one, look at number 2. This one requires some thinking. Unfortunately, we don't have too much time left, so I can't let you think for a long time. F of x equals 0. Well, duh, put this in as a 0. But then the hard part is, how do you solve something that's a big fraction and it's supposed to equal 0? Let me just ask you this. Do you think you want the top to be 0, or do you think you want the bottom to be 0? You want the top to be 0. And you don't want the bottom to be 0, right? Because if the bottom was 0, it wouldn't equal 0. It would equal undefined. So we want the top to be 0. So really, all you'd have to do is take, don't mean to be moving that around, there. You just take that part, the square root of x plus 12, and set it equal to 0. That's how you'd find where the whole fraction is equal to 0 if the top was 0. But you just have to have a couple caveats. You couldn't let x equal, can you do that in your head? It can't be 11 and it can't be negative 11. Okay. So then you'd say square root of x plus 12 needs to equal 0. Then I'd square both sides. X plus 12 equals 0 squared, which is 0. X equals negative 12. There we go. And if x is negative 12, is it going to be 11 or negative 11? No, so it's not going to be a problem. So those are my zeros. Set that equal to 0. Boom, there it is. And the only thing that's tricky is you want the top to be 0, not the bottom. Okay, and then what's the domain of this? We just did a bunch like that, so I don't need to have you do it again, but could you just tell me which, is it at the top or is it the bottom that we set greater than or equal to 0? The top. That part. Not the square root of it either. What's underneath the root. So notice that I do not use the square root. greater than or equal to 0. Greater than or equal to 0. Okay. On the bottom, you'd set it not equal to 0. All right. And the last topic up here, that reminds me of solving x and y intercepts. If I had this equation and I wanted to know what's its x-intercept and what's its y-intercept, do you get if I do this? What am I finding? Think about it. Do you get how it's saying x is 0, and therefore what are you finding? Y-intercept. What if I say this? It's setting what equal to 0? Y equal to 0, and therefore you're finding the x-intercept. Okay, good. Do it. Find me the x and the y-intercept. That's from your last test, by the way. Okay, so here's the idea here. If this is x is 0, I'm finding the y-intercept. So y-intercept is where x is 0. I stick a 0 here, I stick a 0 here, and that turns into 0 squared plus 3 times 0. So it seems like f of x is 0. That's also known as y is 0. What point would it be? Well, if x is 0 and y is 0, it's 0, comma 0. What's special about 0, 0 when it comes to x and y-intercepts? It's both. Think about it. It's the x-intercept. It's also a y-intercept. It's the only spot of all the spots that can be both an x-intercept and a y-intercept. So that actually qualifies as both. So right away, I can just go 0, comma 0 is also the x-intercept. Okay, is that the only x-intercept? No. The x-intercept is where y is 0. So I go back to my function. I put a y is 0. So that part right there is 0. Okay, so 0 equals, and again, you have a quadratic. Man, if there's only one kind of function you should be good at, it should be quadratics, because there's come up so much. So then, how do I solve it? First step, try to what it? Factor it. And if it won't factor, then you would quadratic formula. Good. Could you graph both sides and see where they cross? Yes, as long as you had a calculator. All right, so 0 equals x times x plus 3. There, it's factored. So now it's the answers. 0 and negative 3. So if I wanted to make a list, these are places where y is 0, so I can make something comma 0 and something comma 0. I just figured out that 0 and negative 3 worked. And I already had 0, 0 on my list, but there we go. Okay. Now, that's a pretty thorough review. Remember the options I gave you for reviewing. There's more problems that you can do on the smartboard. They don't have answers, unfortunately. You can watch the videos that are recorded in second, third, or fourth hour. So depending on which hour you're in, maybe watch the other ones. Another option, get smarter. Doing your top 20 would make you a little smarter. Okay? And one last thought, hydration is a good thing. They say you're 10% better at math when you're hydrated. All right. That's all I got for you for today.